Good morning, students. Welcome to video lecturing class on for the subject control engineering. So in the last session, I discussed about what do we mean by block diagrams, what are the significance of block diagrams, what are the advantages, what are the disadvantages, and I've gone through the block diagram reduction rules, how to use those rules, and how to simplify the blocks by using those rules, and also we have solved one problem. So today we'll continue with the problem. So here this is the given problem: reduce the block diagram and obtain the transfer function. So before starting with the solution, first, while copying the block diagram from the question paper, you have to be very careful about these signs. Okay, for example, if in the question paper, if this sign is or this signal is given with the positive sign, hurry if you have taken that sign as a negative, okay, then finally you are going to end up with the wrong solution. That is, you are going to get the wrong transfer function. Okay, so while copying the things from the question paper, you have to be very careful about these signs, with what sign they are fed to the summing points. Okay, so to start with, first you always try to check, is there any series or parallel combination. Okay, so here if you check this problem, this G1 and G2 are in series. That means there is no takeoff point or no summing point between these two blocks. Okay, so I can apply the series rule to these two blocks. Then check for the canonical loops. So here in the forward path you are having G3, in the feedback you are having G2, one takeoff and one summing point. That means here easily I can apply the canonical form to this one. So that is G1 and G2 are in series and G3, H2 are in canonical form. So apply those two rules to reduce this one. So if I apply that one, so G1 and G2 are in series. So product you have to write when they are in series. Replace these two blocks by a single block by writing the transfer function as G1 into G2. Then for this you need to write the transfer function. For that, first in the numerator, the term which is in the forward path block G3 divided by 1 plus this sign depends upon the sign of this feedback signal. Remember, here it is minus, so I have taken it as plus. If it is plus, here I have to take it as minus. Okay, so plus G3 numerator as it is into the signal of this feedback block H2. Okay, sorry, here I have to write it as H2. This is H2. Then you write or you draw the remaining things as it is. Don't try to apply all the rules at a one time. Okay, then now sorry, so here so then you have to check for the further combinations. So is there any series? You cannot take these two as in a series combination because in between there is a takeoff point, and you cannot take these two in canonical loop because in between there is one more summing point. You cannot take these two in canonical because there is a takeoff or there is a block between them. So now check for the associative law. That is, if you look for these two summing points, in between there is no block, there is no takeoff point. That means easily you can interchange their signals. Okay, so I will apply that rule to this. So I will replace this signal to this summing point and this signal to this summing point. Remember, while replacing, along with the sign which they are having originally, you have to replace them. Okay, this is fed with the minus and this is also fed with the minus. Now if you check it, this combination forms the canonical loop. So for this combination, you write the transfer function. G1 G2 divided by 1 plus G1 G2 into H1. Again here I taken it as plus because this signal is with minus sign. And this term as it is G3 divided by 1 plus G3 into H2 and this feedback signal. Now if you look at these two are in series. So you can write the product of these two and you can replace it by only one block. So that time it is going to form the canonical loop with this H3. If you replace these two by single block, then in feedback also you are having one single block, take off one and summing one. So directly I have written here the canonical loop equation. That is, if you take the series combination, you have to write the product G1 G2 G3 divided by 1 plus G1 G2 H1 into, again one more bracket inside the bracket, 1 plus G3 into H2. So this term, when you replace these two by a single, divided by, because it is forming the canonical loop with this H3, 1 plus this numerator as it is into the signal or transfer function of the feedback block, that is H3. Okay. So now here for the simplification, numerator you keep as it is. In the denominator, if you rewrite it as G1 G2 G3 into H3 divided by this, if you take the LCM, that time you need to cross multiply with this 1 and this will be A by B and C by B. So here denominator are going to be same, so directly we can cancel them. So C of S divided by R of S will be G1 G2 G3 divided by this 1 is multiplied with this denominator, 1 plus G1 G2 H1 into 1 plus G2 into H2 plus G1 G2 G3 into H3 is the answer, that is the transfer function. Okay. Then moving further, the next problem. So here also it has asked us to reduce the block diagram to obtain the transfer function. So as I said, first you need to check for the series or parallel combination or any canonical loops. Okay. So here if you see, these three are in series, G1, G2, G3, and all are fed with this plus sign. If any one of this is fed with the minus sign, that time you have to consider that sign also. So here G1, G2, G3 are in parallel, and for the simplification purpose, I will shift this takeoff point after this G4. Okay. So when you shift the takeoff point after G4, that time it is going to have G4 also. Yes. So here we don't have the G4 signal because it is before G4. If I shift here, it is going to contain G4, but that signal should remain same. For that I need to divide this G5 by G4. Okay. That is shifting of takeoff point after the block. If you know that rule properly, easily you can understand. So G1, G2, G3 are in series. Written it and draw this portion as it is. I will shift this takeoff point after the G4, shifting here. That is the reason why for this G5 I am dividing it by G4, because before shifting it doesn't contain G4 term, G4 signal. But when you shift here, it is going to have the G4. But if you divide it by G4, your signal will remain same. Then remaining terms as it is. Now you can see this block as it is. Here this portion is making canonical loop and this portion is making canonical loop. And what about this? It is not the canonical loop. It is the parallel combination, because this is in forward path and this block is also in forward path. Remember, for canonical form, one block should be in forward and one block should be in feedback. But here both are in forward path. Here no block means there is a block whose value is 1. Okay. So you can take these two signals are in parallel combination. Okay. So G1, G2, G3 For this, I am writing canonical equation, that is G4 divided by 1 plus because here it is minus G4 into H1. Next, this combination I am taking as parallel combination. If they are in parallel, you have to write the sum of the individual blocks, 1 plus G5 by G4. Next, it is fed to this. So here again it is forming the canonical loop. So it is G6 divided by 1 plus G6 into H2 and G7. So now if you consider all these 5 blocks are in series. When they are in series, you have to replace with the single block by writing their product. So here, written the product and H3. Now this block is in forward and this block is in feedback, single summing point and single takeoff point. So we can take it as a canonical loop. So to write the transfer function, in the numerator you write the transfer function as it is, divided by 1 plus, again here it is plus because it is fed with minus sign, this term into this term. Okay. So if you simplify that, you get the transfer function as G1 plus G2 plus G3 into G4, G6, G7 into G4 plus G5 divided by this term. So here for the simplification, here if you take the LCM for this, it is going to be 1 plus G4 into H1 into G4 into 1 plus G6 into H2. So that denominator will get cancelled with the denominator of this numerator and that term will come here. That is 1 plus G4 into H1, G4 into 1 plus G6 into H2. This is a simplification procedure. Okay. So once you simplify that, you will get the transfer function. Then moving further, the next problem. Here, reduce the block diagram. So first step is you need to check for the series or parallel or canonical loop. If you look at this problem, there is no series, no parallel, no canonical loop, or you cannot apply the associate law. Okay. So here what I will do, I will shift this takeoff point towards this side. That is, I will shift this one before H2. So if I shift this one before H2, here it was having H2, but when you shift here, it won't contain H2. For that reason, I have to multiply with this signal with H2. Okay. So look here. This portion as it is you redraw, and here in the feedback, I transferred that the signal to this, that is here, and I added one more block to multiply that H2, so that the value of this signal which is fed to this summing point will remain same. Initially it was having H2, now also it is having H2. Okay. Then I will shift the takeoff point behind H1. Okay. So I will shift, this is the H1, behind means here, because it is, you are in a feedback path. But when you are in forward path, that time behind means before. Okay. So now I will shift the takeoff point behind H1. So that time, so here it is having H1 and H2, this signal. If I shift this signal behind H1, that time it is going to have only H2. So I need to add one more block whose value is H1. For that reason, it is H1. And similarly, this is H1, and here also it is H1, H2 and H3. So I am shifting these two signals before H1. So if I shift before H1, I need to add that transfer function or signal to those feedback signals. For that reason, it is multiplied here H1, and here also it is with H1. And here it should remain as it is, H1, H2, H3. Now if you see, these two are in series. Okay, so H1 into H2 will be the feedback block. So it will form the canonical loop with this G3. Here write the canonical equation, that is G3 divided by 1 plus G3 into H1 into H2. Here plus means it is having minus feedback signal. Then this G2 and G3 are in series, write the product and apply the canonical loop with H1. So once you write that one, this term or this block will be in series with this G1 and it is going to form the canonical loop. So first you write the product as G1 G2 G3 divided by 1 plus G3 H1 H2 plus G2 G3 into H1, and feedback signal written as H1 H2 H3 because these three are in series. Okay. So now it is forming the canonical loop with this equation. So G1 G2 G3 divided by 1 plus, this term remains as it is in the numerator, divided by 1 plus this term into this term. So when you simplify that, you will get the transfer function as G1 G2 G3 divided by 1 plus G3 into H1 into H2 plus G2 G3 into H1 plus G1 G2 G3 plus H1 H2 H3 is the transfer function. Then moving further, here one more problem, reduce the block diagram to obtain the transfer function. So here also if you check, none of the blocks are in series or parallel or canonical loop, but here we are having these two summing points. So we will try to merge these two summing points without altering their signals or without changing in their signals. So for that I will merge these two and I will replace it by a single summing point. Here I have taken there is a plus 1 as an extra block because on this one is fed with the positive sign and here also it is fed with positive sign and here this also fed with positive sign. Instead of this one as with plus sign, if it is fed with a minus sign, okay, so that time I cannot put minus here because it is having one more signal which is coming from here. For that reason I have introduced one more block with plus 1. Similarly here also for this one also it is plus 1. Okay, so now here there is a correction in this statement. Here we are having a one block with H1 which I have considered in the next step. Okay, correction is here we are having a block with value is H1, that is a feedback block. So that's why it is plus 1. Okay, if it is minus, that time you have to write the transfer function in that block as minus 1. Now if you check, this G1 and this G3 are in series, parallel combination. They are not forming the canonical loop here because both are in forward path. But this G2 and H1 are in canonical form. Okay, so write that combination parallel and canonical G1 plus G3 and this block G2 divided by 1 minus. So here I have taken it as minus because it is fed with plus sign, G2 into H1. Now if you look here, these two are in series, write that one, product as the transfer function G2 into G1 plus G3 divided by 1 minus G2 into H1, and it is forming the canonical loop with this H2. So write the canonical equation, that is in the numerator this term divided by 1 plus because here it is fed with the minus sign, numerator term into H2. Once you simplify that, you will get the transfer function as G1 G2 plus G2 G3 divided by 1 minus G2 into H1 plus G1 G2 H2 plus G2 G3 into H2 is the transfer function. Okay, so these are some of the problems on block diagram reduction. The only thing is you have to be careful while using the rules. Okay, and while you have to be very careful the sign around the summing points, and you have to be very careful about the direction of the signals. It is not like always you will be having the canonical loop when they are in parallel combination. Okay, sometimes you have to take them as in parallel combination because both the blocks will be in the forward part. Okay. If you are having any doubt, you can leave the comment in the comment box. Thank you.